Welcome to the demo of virtual prototype start package from CircuitSutra. In this demo, we will demonstrate the package for USB. Before we start the demo, let's have a quick look at the content of this package. VPQSP USB. It has a TLM USB protocol which defines transaction level interface for communicating between two USB modules. It has a convenient socket, TLM USB host socket, which encapsulates complex USB host controller protocol inside it. It has a TLM USB device socket, which encapsulates complex USB device controller protocol, so that if anyone wants to develop USB controller or USB model, no need to worry about implementing this complex protocol. They can simply create instance of this socket and call the APS. It has a model of USB OSPC device controller which encapsulates the USB port on the OSPC so that we can connect a USB stick with a virtual model, and it also comes with a sample model, XHCI model. It has a model of USB OSPC host controller which encapsulates the USB host controller of the OSPC so that it allows to detect the model of USB device on the OSPC. It comes with a sample USB device model which contains model of mass storage device and a Linux device driver. In order to demonstrate this, we'll be using CST board, which is a virtual prototype of sample SoC based on the ARM Cortex-M5 CPU, which is capable of booting Linux and it can be used for embedded software development. The models present in the CST board are developed using CircuitSutra modeling library and VPQSP. This is a high-level block diagram of CST board. It has a model of ARM CPU Cortex-M5, which is based on the QEMU. Actually, we have extracted the CPU core part from the QEMU and developed a systemc TLM 2.0 wrapper on top of that, so that it can be used in systemc based virtual platform. It has a TLM 2.0 bus and models of several peripherals. CST board has models of minimum peripherals required to boot Linux like memory, RTC, timer, interrupt controller, etc. Apart from that, it also has various models from Quick Start package. In today's demo, we'll focus on XHCI model, USB OSPC device controller, USB mass storage device, USB OSPC host controller. Before starting the demo, let's have a quick look at the source code of the CST board. This is the header file of CST board. It has instance of all the peripherals in the CST board. And here is the instance of XHCI model, OSPC USB device model, USB device controller model, OSPC USB controller model. In .cpp file, here you can see the XSCI model is registered on TLM 2.0 bus in this address space, so that whatever TLM transaction comes to this address space will be handled by XHCI USB host controller. And the XHCI controller is connected to the OSPC adapter, which is nothing but the OSPC device controller model. Here you can see here the USB device model, which is registered on the TLM bus in this address space, so that any transaction coming to this address space will be handled by USB device model. And the OSPC host controller model is connected to the USB device model. The steps for running the CST board is given in the document quickdemo.txt. The first step is setting the environment. For this, we are providing a script cst setup.sh. So in this, you have to set two variables. One is cstril and next is cst-config file. In cstril, you have to provide the path of the cst release folder, where we have the setup for running the CST board, so that it can pick the right DLLs. And here you have to provide the config file.lua, which is a configuration file for configuring the various models in the CST board. In order to configure USB OSPC adapter, so here you can provide the vendor ID and product ID of the USB stick which are going to connect to the OSPC, so that it can be visible in the virtual platform. I have already updated this vendor ID and product ID of the USB stick which I am going to connect. So next step is running the CST board. For this, you have to run this executable from the location CST board bin Linux folder, and you have to provide the path of the ZImage and bootloader to the executable. And the steps for running the VPQSP USB is listed here. Here there is two cases. One is for USB host controller and OSPC USB device model, and the second case is for USB device controller with OSPC USB controller model. So what happens actually here is like for this, first we will be connecting a USB stick to the OSPC, and it must be visible in the VP, and we'll write some data and text to the USB drive which is attached in the VP, and we will unmount. After that it must be visible in the OS machine, the files which we created earlier. And in this we'll be attaching a USB device model to the OS PC. Now to make VPQSP demo work, we need to do some prerequisites for this too before running the CST board. This is given in the document readme VPQSP USB.txt. Prerequisites for host USB device model is like first you have to set the vendor ID and the product ID which you are connecting to the host PC in the config file.lua. This you can find the vendor ID and product ID can be found using the ls USB command on the host terminal. And you have to provide the user the read and write access permission to the USB stick connected. So here you can see right now there is no USB stick attached. Now I will try to attach a USB stick. So now we can see here a new USB stick has been detected by OS PC, and you can see here also. And I'll delete this file. So this I have already updated vendor ID and the product ID. Now I need to provide the read write access permission for user for this bus and device ID. Sudo change mode bus USB, and I have to provide here the bus number and the device number 012. So this is done. Next the prerequisites for host USB control model. For this we have to install a driver, that is a USB virtual host control driver on the host PC, so that the USB device model in the VP can be visible in the host PC. For this we are providing a script install driver.sh. This will install the USB virtual host control driver on the host PC. I have already installed this driver which is present in the location utilities dependency package USB virtual host control driver Linux. Now we are ready to run the CST board. Here I am providing the path of zimage and bootloader to the executable. This is the CST terminal model. Here you can see the Linux boot up messages. This is the CST display model. Here you can see the list of peripherals identified by the Linux kernel. This is the USB stick which attached 8564 and product ID 1000. And SDA is the device name for the USB stick attached. So now first I will try to run the steps for demo for case 1. So you can confirm with this command that the USB stick is attached to the VP. Now I will create a folder and I will try to mount this device on this folder. I'll try to mount so that I can write some data to the pen drive. VP to the file. I am redirecting to the file esb.txt. So you can confirm with cat command. So you can see the text is been written to the esb.txt file. So now I'll unmount this pen drive from the VP so that the same text file which we created in the VP must be present after unmounting as well in the host PC. This will confirm the demo for USB host controller and host PC USB device model. Now I'll unmount and I will close the VP. So now I'm connecting the USB stick to the OSPC, and now we must see the files which we created in the virtual platform. So you can see here usb.txt, the message we return to this file. Welcome to VPKSP demo. This completes the demo for case 1. Next thing is like for case 2, as I told before, I need to install this driver. Show how to install. CST release folder, utilities, dependency package, USB, Linux, install. The driver is installed now. Now when I run, you must see a 2.0 MB USB master storage device attached to the OSPC once the Linux is booted up. So you can see here a 2.1 MB USB master storage has been now detected on the OSPC. You can create some file, folder, etc. This completes the demo for case 2 as well. So now we have completed the demo for VPKSP USB for both USB OS controller and OSPC USB device model, and for USB device controller with OSPC USB controller model. All the models in the CST board are developed using CircuitSutra modeling library, which is nothing but a collection of convenience class and utilities to ease the model development activities. It has a model generator utility so that you can define some interface in some Excel sheet. It will generate the model, test bench, etc. for you. So the primary benefit of using CSTML is that whatever model you develop using this, it will automatically become tool independent so that it can be easily integrated with any virtual platform tool. Another benefit is that it is platform independent so that the models will support Linux 32, Linux 64 and Windows 32 and Windows 64 platforms. The models in the CST board, we are also using a virtual prototype quick start package, which is nothing but a library of basic models and modeling infrastructure, which contains TLM protocol and convenience socket for the popular chip interface, and it also has backend modeling infrastructure to access the host computer interface. So in today's demo, we are using 2 backend models. One is USB OSPC device controller, and another one is USB OSPC host controller model. When virtual platforms are developed using CSTML and VPKSP, it can result in reduction of development efforts up to 80% for complete SOC or electronic system. This completes today's demonstration. Thank you.